So yeah, the idea here is to get a linear movement in order. So like I did yesterday, I'm just going to work with the preloaded sprite, but you'll personalize your sprite. All right. So what we want to do is take into account the position of the sprite initially, and then the position of the sprite after the movement that we want it to make. All right. So this position is negative 188, 106. And let's say I only want it to go to this position right here. Guys, just if you could. Negative 30, comma negative 33, 23. All right, so these are our coordinates. We first need to write the equation of the line that passes through these two coordinates, and then we have to get that into Scratch. All right, so we use, or I encourage you to use, y equals m times x minus h plus k, the point slope form of a linear function. All right, so m is the slope, h and k is a point on the line. Linear relationships and proportional relationships are going to come back over and over again, not only throughout this course, but throughout any kind of coding that involves movement. We need to get this concept down. I mean, we did a lot with it in Algebra 1, and actually in every math class that you would be taking, have taken and would be taking on the high school level. You deal with linear functions all the time. It's almost always the first thing you cover. All right, so got to get good at it at some point. So m is equal to change in y over change in x. All right, so negative 23 minus 106. You know, do it in whatever order you want as long as it's consistent. Negative 30 minus negative 188. Now, it's up to you if you want to try to do this by hand or using technology. It really is up to you. If you use technology, I have calculators that you could borrow. Let me just pop one of them in here. That's not the calculator. This, oh wait, actually no, this is not what I wanted to do. Here we are. I use the NumWorks calculator. So these are the calculators, my loaner calculators. So if you wanted to use one of these, you're more than welcome to. I'll make sure the set is out on a daily basis from now on. So negative 123, negative 23 minus 106. So negative 129 up top, and then negative 30 minus negative, or you could just say plus 188. Calculator understands it either way, so we're good. So 158. You can make a fraction out of it in the NumWorks calculator. And if it can be reduced, it will get reduced in the calculator itself. All right. Otherwise, it'll give you a decimal approximation. And you could go with either one, but the more accurate we are with our decimal approximation, the more precise our movement is going to be. But, you know, you do have some wiggle room based off of pixel size and things like that. All right. So that's the equation. Oh, well, not yet the equation. That's the slope that we want to get into our equation. The only other thing that we would want to do here is choose one of the 2 points to put into the formula. I didn't mention this yesterday, but I typically choose, if I'm dealing with an ordered pair that's going to be the end point of one movement and a starting point of another movement. Like, for example, let's say your golf ball is going from here to here, and then at that same point it's going here. You want to have the point that's in common between the 2 line segments. Right? That way you can recycle a lot of your work. Right? So I always choose, when it's the first line segment, I always choose the second point, because then I could duplicate my stuff and I'll have a little bit of an easier time. So negative 129 over 158 x minus the negative 30 plus a negative 23, but you can skip that part of it and just go right to the simplified form if you're comfortable doing that. All right, so this is what we want to get into Scratch. All right, this formula here. So we start building that. Well, looking at what I have division, multiplication, addition, and subtraction. So I need those operators. All right. So division, multiplication, addition, subtraction. So all 4 of the basic functions. I also need a place to start. So I'll do it when the green flag is clicked, just for demonstration purposes. But my operators: addition, subtraction, multiplication, division. Right in the division one off the bat, you could type in the 129 over 158. All right, that's going to be the first part of the multiplication component, but you could really just, piece it together in a way that makes sense to you. Like, for example, within the parentheses, I have an x plus 30. So I need an x here and a 30 here. I don't have my x yet. All right, if I type in an ordinary x, it's not going to understand what I'm trying to do. All right, so we go down to variables. We make a variable. All right, they give you a default, but that's not helpful for us because we might need multiple variables. So we define it. Oh, in this case, we definitely do. But in any ordinary situation, you might need more than one variable. So my variable 1, my variable 2. I don't know if that's going to be as helpful as naming it something that describes what the actual what the variable actually does. All right, we set it for this sprite only because if we set it for all sprites, then anytime I use an x, even related to another sprite, it's going to follow it. Well, it might get confused and just have a break, but it's going to follow the definition, the most recent definition of x, which may not be what you want. All right, so for this sprite only, we call it x. We can uncheck it, make a variable, call it y, uncheck it, and then pop that variable x into the x plus 30, or into the plus 30 to make it x plus 30. All right. So that gets plugged into the subtraction one because from that we're taking away, well, actually, sorry, hold on, let me not do that yet. Let's do the multiplication first because we already have the pieces already assembled for the multiplication, so we might as well just take care of that. All right, so division goes in the left piece, addition goes in the right piece. Now we're saying that we're taking negative 129 over 158 and multiplying it by the expression x plus 30, all in one shot. All right, so it's following the order of operations. The last thing we want to actually have happen is subtraction, so it makes sense to put it in this order with the 23 off at the end. All right, so now I have essentially the right-hand side of the equation. I need the left-hand side of the equation. All right, so I'm going to set my y variable to be equal to this expression. So I pop that in there. Now I have my equation. So I want to build and really establish the parameters of the movement. So the first thing that I would want to have happen is I want this sprite to go to the initial point that I have indicated, or had indicated. It's right here, negative 188, 106. So go to those coordinates, negative 188, 106. That should be my initial movement. All right. I need to define the variable x, right, to align x with the starting point here. So I'm going to set my x variable to be equal to the negative 108. All right. So set x to negative 108. All right. So that will put the sprite at the initial location. So I'll just hit that. It'll put it to the initial location, and it'll establish that the x variable is worth negative 108. All right. Now I want it to move. So I go to my repeat until function. I want it to stop moving when x is negative 30. All right. So I'm going to grab an equality operator. Well, it's in the operators are always in the green, so you could you just click on the thing that you're looking for. But equals. I want x to eventually equal negative 30. So I'll type in the negative 30. And that goes in the hexagon. That's my repeat until. So if I follow this code right now, it's not going to move anywhere because I haven't told it to, except for that initial location. It's going to define x to be negative 108. And then it's going to repeat this command until x becomes negative 30, but I've never told it to change x. All right. So we're already at the starting location. I want to change my variable x by 1 unit. All right. If you want to impact the speed of the sprite, you play around with the change x by. All right. You want to go slower, make it smaller, closer to 0. If you want it to go faster, it'll skip points. If you make it like change x by 2 or 5 or something like that. All right. The one thing that you might run into as an issue is if you make the change in x too large, it might miss the negative 30 on the back end. All right. So if it doesn't actually equal the x value, if it doesn't actually equal negative 30, at some point the code will go on forever and ever. It'll be an infinite loop. All right. So what you have to do is you have to make sure that when you're changing your x, you're changing it by something that will allow consistently the movement from negative 188 to get to negative 30. So you might want to go by, well, definitely 1s will work, but maybe you go by 2s, even number to even number. That'll work out. All right. If you go by 10s, you're always going to land on an x value that ends with an 8. All right. So you'll never get to a negative 30. So if I go by 10s, I'll have an infinite loop, and that'll be a problem. All right. So I'll show you that in a minute. But now I have x changing, but I still don't have it going anywhere. So I'm going to select go to, not a particular location, but a variable location xy. Okay. Because what it did is it computed the y value for the x that we said, which was negative 1. Oh, you know what? I put in negative 108. I meant to put in negative 188. So let me just fix that. All right. So it's at negative 188, comma, whatever the y is at negative 188. All right. Which we know to be 106, but it does its own computations. Then it's going to increase by 1, which makes it negative 187, comma, whatever y is at negative 187. And then increases and so on and so on. But I want it to actually go to that new location before adding the next value. All right. So we start off at negative 188. We compute the y value. All right. We're already there, so it's fine. We started off at negative 188. We compute the next value by adding 1 to it, going to that location. You could actually, this order here is not really too critical. I mean, you could play around with it, but if you want to go to that location first and then change x by 1, that's fine. Right? Either way is going to be okay, because all it's going to do in the first step, if you put it in this order, is stay at the initial location because I haven't changed x. All right. Here, oops, it'll change x and then go to that new location. So however it works. Anyway, I'm going to run the script. And just verify that it got to something very close to what it should have gotten to. All right? It's not going to be perfect because you have, I mean, this is a sprite that's very large, and I have it going by little tiny pixels, coordinates that are related to pixels. So there will be a little bit of inaccuracy along the way, but as long as you're in the neighborhood very close to what you should have gotten, we should have gotten negative 30, comma negative 23, right? So we're off by 1. So maybe you swap the order and do it again and see where that gets you. Negative 30, negative 22. That's probably a little bit better, I would say. I mean, neither of them, you see how the order of those last two blocks really didn't matter. One may get you slightly closer than the other, so technically this one's a little bit better, this arrangement. But yeah, I mean, it's not otherworldly better. Yeah, it's kind of like if you just imagine you're playing golf and you go to sink a putt, and the difference between your putt and the person that you're going against was that yours went to the very edge of the lip of the cup and then went in. So it kind of technically stopped at the lip, and the other one was more of a even drop into the cup. They both went into the cup. So you both sank the putt. One of you was off by a millimeter, but that didn't really make a difference. All right. So that's an example of block code for this sort of thing. All right. Now, I did mention yesterday at the bottom, there's the little backpack. If you haven't explored the backpack, the more things you do in Scratch, the more you're going to find this to be valuable. If you open your backpack, you see I got a bunch of things in there. If you just put together a pretty intricate piece of code that you think to yourself, man, I never want to do that again, put it in the backpack. It'll save it there, and you'll have all of your scripts in here. You can grab them out as needed. For example, if I needed this one, you know. But you can save it, and it'll be there. All right. Always make sure you title your Scratch, because obviously you want it to be searchable. All right. So if you go into the Regression app and type in the coordinates of your data set, right? So we had negative 188, 106, no, 106. Then we had negative 30, negative 23, I already forgot. Negative 30, negative 23. I have extra data in here, so I clear them out. If you go to Graph, there's an option that says Regression. If you select Linear Regression, it's in a different form, but it gets the job done. It'll give you the line that best fits the data, and then all you'd have to do to figure out what that line is go back into the command Regression. And you'll see an equation that'll fit those 2 points, and you wouldn't have to do the algebra. All right.